So, Peter, you are Senior Sales and Support Manager at Admesy, and you will present about color measurement solution for micro-LED displays. So please, Peter, you can start your presentation. Thank you.
So today I want to talk about the challenges and the special needs you have for micro-LED measurement. So micro-LED is one of the technologies which has started to become bigger and bigger over the last years, or will become bigger and bigger. So that is the future to some extent. But micro-LED and other display technologies have special needs regarding their measurement. So they offer special advantages like a very high contrast range. They allow high dynamic range pictures with a very low luminance value with very high luminance values. So for low luminance values, you see displays easily going down to 0.01 candela per square meter, or typical real-world low luminance value is 0.005 candela per square meter, but that can be even lower. If you turn off a MicroLED display, then it's basically dark and you just have the reflection of the ambient surround. The second important parameter you have to look at is the high luminance value, and that is easily 3000 candela per square meter or higher. And you also are looking more and more into wider gamut displays like Rec 2020 from the TV industry, extending on the usual sRGB gamut, where you realize very saturated colors by creating very small band spectra. And those can pose challenges for the measurement as well. And like we just heard, microdisplays are especially suited for AR applications. So we need the possibility to measure those small displays, either as a complete display as such, or like we heard in the talk before, also for pixel level evaluation. And finally, especially in the development phase, you need to take care that you design everything so that you can get a very good viewing angle for color, gamma, and contrast, and don't have any problems. So a MicroLED potentially is very good in that, but you have to take care in the design phase. Now I will go through quickly over what measurements we are looking at. The first measurement we are often interested in is the luminance, and the luminance is the value we measure which describes basically our brightness. The brightness is often, or luminance is often called brightness, which is wrong, technically speaking, because brightness is a visual perception, but it's directly correlated. So in that sense, you can think of luminance really being the brightness. The second measurement we look at is the chromaticity value. So that is typically expressed in small xy, but can also be u prime, v prime, or sometimes you also see it expressed as a dominant wavelength, for example, and purity. And those values can be calculated from the three stimulus values x, y, z. And then they describe then a specific color. Finally, in some applications, you are also interested in the spectral power distribution. That is not so much for production applications. Typically, there you are mostly looking for the color value as such, the three stimulus value. But especially in the development phase, we are often very much interested to measure the spectral power distribution very accurate. But also for calibration, for production purpose, the spectral power distribution needs to be assessed also very accurately. So there are basically two types. You can measure all those three measurements: luminance, XYZ value, trim stimulus, or the spectrum. You can either make a spot measurement where you have a look. Here is a larger TV display, but the same holds true for a smaller display like a smartwatch or an AR display, where you can measure a single spot, which you typically will do with a colorimeter because it is very fast. Or you can use a 2D imaging device when you want to have a spatially resolved image measurement. That can also be done with an imaging colorimeter, which uses very accurate filters or